Alright, so this particular example wants us to find the interval within which is defined, right? But let's do this. Let me break it down before we even start. First of all, when we are trying to see if it's the interval that is differentiable, we want to see if a function is differentiable at a point. What we do is that we find the limit, right? As x is approaching 0, right? And when we find that, we usually get to know whether it's differentiable or not. And if it is differentiable, we end up getting a valid result, right? So this one, what we can do is that we find the limit, right? And when we find the limit, we end up getting a function, right? We get a function. And then with that function, we have to find the domain of the function. And when we find the domain of the function, then we'll get to know when the function, when we find the domain of the function, we'll get to know the region within which is defined and not defined. And from that domain, we find the interval, right, within which is differentiable. So that's what we do. So right, the first thing, let's find the limit now, right? So let's see. So differentiable, right? And so the limit will be this way as h approaches what 0, right? And there's a function will be of this form, f of x naught. I'm just writing this out the last time. X naught, and then we have each, right? So we have this one, the inside, the whatever that we are putting the function on is inside, right? So this will happen. So we'll have x naught plus h, right? So that will be square root of x naught plus h, right? Minus 1, right? This is all for this. Then minus this side, right? So let's see. That will be the x inside is just x naught, so that will be square root of x naught minus 1, right? And then we have here to be h. Looking at this one, we can't do anything to it again, aside the fact that when we rationalize it, that we can cancel the h out, take out all the h, so that we get what we are looking for, right? So now we are rationalizing. Rationalizing means that we multiply the numerator and the denominator by the, what do you call it, this particular term for it. It's like the opposite of this whole thing here. So let's see. Opposite in terms of the sign, as in whether if it's negative, make it positive. So to be this way, minus 1, right? And then minus 1, all on each, right? Now we'll have to get the opposite of all this here. So let's see. Okay. And when we do that, we mix whatever that we are doing simple, like we are rationalizing it. So let's see. That help us to get a way to eliminate all the h that are in. That way we can make it our work easier. So let's see. So here will be okay. We are using the opposite, so positive. All about the same thing. Yeah, so this will happen. We're now getting this squared minus this squared, right? So here will be, then again, limit each approaching 0. The top will be L0 plus each, right? Minus 1. And then we'll have this one, morning. X0 minus 1. And then this side will be just e times the whole thing, right? H, this side is H. H here. And then plus square root of x0 minus 1. So let's see. When we open this one up, we end up getting, so let's see if we can answer. This one takes care of this. This one takes care of this. This one ends up taking care of this. So we end up getting just each at the top. So in the final each at the top will also cancel this each out. Hey, see me, man. So we end up getting just one all on everything here. Minus 1, and then we get this one. And now everything has been taken out clearly. So now that x is approaching 0, h is approaching 0, this is what we end up getting. We end up getting 1 on square root of x, right? Not minus 1, and then square root of x not minus 1. We end up getting this. Let me write this well. We end up getting 1 on 2 square root of x not minus 1, right? In fact, this x naught, I just wrote that so we know that we're actually trying to, you can use anything that you want to use, right? So now that we have this, we have to find the domain. The domain is when the range within which the function is defined, right? And looking at how this function is, it's only defined when this x naught here is actually greater than 1, right? But the moment is 1, we end up getting 0. The moment is 1, we end up getting 0. Sorry, we end up getting 1 here, and then minus 1, that'll make it 0. So everything here becomes 1 or 0, which we don't want to see, right? We don't want any 1 or 0 something. We don't want anything divided by 0. So that way, the only way we can make this defined is when the x naught is greater than 1, right? So that's the domain. The domain is such that, because you're talking about row numbers, let me try and write this out just fast. Talking about row numbers. So the domain row numbers except row numbers where x naught is greater than 1, right? So this is what we have. Because the moment is 1, we end up getting 0, 1 or 0. We don't want it that way. We want it to be greater than 1. And then within this, because 1 is not part, we can write it this way. Any number from greater than 1 but up to infinity will be defined. So we can write the interval this way. Because 1 is not part, it's open on the side, and then 1, right? And then we end up getting infinity here, right? Yeah, so this ought to be. But so actually, for the domain, 1 could be part, right? Greater than or equal to 1. This will be minus 1 minus 1, then here will be 0. Square root of 0 is 0, 2. That will make everything here 0, 1 or 0. But for the interval that we are looking for, we don't want it to be that way. So for that one, 1 is part, 1 is not part, right? By infinity to we don't know where it ends, so that's why I write the interval this way.